Hey, good afternoon, everybody. Thanks for taking the time today. I'm Bill Stearns. I work with Active Countermeasures on the RITA and AI Hunter projects, as well as some other smaller ones. We're putting together a talk today for people to introduce them to the Raspberry Pi. And this one is we'll kind of go through what that is. You don't need to have any background on what the Pi is. We'll talk a little bit about how it's going to get used as a network sensor, how it can be used for other purposes as well, and give you some links to different ways to make this happen. Want to just give a quick reminder that for those of you who couldn't make it out to South Dakota because of the registration was full, we do have another one coming up, Wild West Hacking Fest coming up for the first time in San Diego, March 11th through March 13th, with training on the 10th and the 11th. And so if you're interested in that, go to wildwesthackinfest.com, I believe is the URL. And if that turns out to be incorrect, put a note in questions and we'll get you the corrected one. Thank you to Black Hills Information Security, to Active Countermeasures, and to Wild West Hacking Fest for sponsoring the talk today. We really appreciate it. If you haven't already pulled them down, go to www.activecountermeasures.com/raspberry_pi_sensor, and that directory will have this talk, a spreadsheet with a list of parts that are recommended, and some scripts that'll help you do the setup. All right. We'll have that URL up again, but I'll just read it off once more, www.activecountermeasures.com/raspberry_pi_sensor. And you can pull those down anytime. What we want to do is talk a little bit about what the Raspberry Pi is, where to get the parts for it, how to build the system, how you'd set it up as a network probe, take a look at the data that you get out of the system, and also a brief coverage of some of the other cool things you can do with a Raspberry Pi. What are the goals? Well, if I'm stepping into a customer's site and I want to put a quiet sniffer on their network as part of a pen test, I want something that's going to stand just quietly out of the way. If I walk in with a 2U rack mount server, it's going to be harder to hide it behind the begonias in the corner. So instead, I'm going to come up with a small and inexpensive system that's easy to buy that can do sniffing for me. I may have different tools I want to use. We'll talk today about TCP dump. We'll talk about using Bro and Zeek, and we'll keep it open to the idea that you can use basically any sniffer that you'd like. The system that we're going to use is able to keep up with moderate speed networks. It can run without having an IP address on the sniffing interface. And we want something that can be used by both attackers and defenders. I'd love to be able to have a sniffing interface as a defender to look for malicious traffic. The red teams want to generate the malicious traffic. You can do both with this one platform. So what is the Raspberry Pi? Well, first off, it's a small computer designed in England by some people at a university that realized they weren't getting enough people signing up for the computer science courses. And their logic was that there isn't anything down at the teenage years to encourage people to come in and learn about computers, computer architecture, computer operating systems. When you're handed an iPad and you've got this closed platform with no way to extend it and no way to go and interface with the rest of the house, you just don't learn much about how computers work. They wanted something where people get real hands-on time and inexpensive enough that it wasn't just available to rich students. So the Raspberry Pi can run basically the Linux operating system. There are other operating systems available. We're going to talk about Linux today. If anybody's wondering, I'm going to divert it off right now. There is a version of Windows that will run on this. It is not a full version of Windows, and it is so painfully slow that it's not practical for use. That said, if you're comfortable with Linux, we're on our way. Anything you could run on a different Linux system, you can run on a Raspberry Pi. We're going to talk about the Raspberry Pi version 4. And that's this unit right here. This is the new version that came out, I think, end of June or early July. Reasonably powerful quad-core ARM processor, 1.5 gigahertz, and it has 1, 2, or 4 gigabytes of memory. Just a moment, please. I'm going to just check and see if we are going to cover this on the next slide. Yep, we're going to talk a little bit about each of those. So this is the layout. The port that we're interested in is the gigabit Ethernet port, and that's where we'll do our sniffing. But we also have 4 USB ports for additional network interfaces or storage or whatever, keyboard, mouse, whatever you'd like. Down the lower left, there are 2 micro HDMI ports, meaning that you can go up to 4K displays on both. This can really be a functional desktop computer. It's never going to be blazingly fast, but you can do 30 frames per second video on one of those. It's not quite good enough to do 30 frames per second on both of those monitors at the same time. It uses a USB-C power supply. We encourage you to use the one that comes with the Raspberry Pi. There's some very, very subtle compatibility issues. If you just buy the inexpensive one they have, you're all set. It also has Wi-Fi and Bluetooth as well. So if you want to use a Wi-Fi interface for accessing the Pi and then use the wired interface for sniffing, you're all set. It has 2 USB 3.0 ports, and I believe that those are 5 gigabits per second, and that's plenty fast for high-speed storage. It also has 2 USB 2.0 ports, and you can do things like keyboard or mouse or lower speed communications on that.
Hey, Bill.
Yes, please.
So a quick question. I think that we probably want to encourage everybody to go with the 4 gig model, right? I mean, that's just more memory is always good, and the cost isn't that much different, is it?
It isn't. There are 3. You have 3 versions you can buy the Raspberry Pi for. 1 gig is $35, 2 gig is $45, and 4 gig is $55, which is still totally affordable. The only time you'd think about going for the 1 gig version is for a very, very limited application, perhaps like a DNS server that you're putting in or an SSH gateway, but you generally want to do 4. All right.
So, a couple questions.
Yes, please.
Can the Pi run any ARM64 Linux, or is it only certain distros?
There are some that are pre-packaged and ready to go, and you'll find that your life is going to be a lot easier. If you're using this for the first time, just go with Raspbian, R-A-S-P-B-I-A-N, the default distribution for the Raspberry Pi of Debian. That said, I don't know of any reason why it wouldn't work with others. If you're putting the distribution together yourself, there's going to be a certain amount of work involved that could be put into other pieces.
Yeah, I made that mistake. Just so you know, I made that mistake. I was like, oh, I don't want to use that distribution. I'm going to use something else. And a few hours later, I went back to Raspbian.
There we go. Yep, a good way to learn. Absolutely. Jason, do you have some others?
Yeah, this question's come up a few times. Will Pi version 3 work for this, or only 4 and above?
3 is fine. But I need to give you a warning about the Pi 3. Both the Pi 3 and the Pi 4 have gigabit Ethernet physical ports. The quirk on the Pi 3 is that the Ethernet port is run through the USB controller on the Pi 3, and that limits the port to 300 megabits per second. That's the maximum it can transfer, even though the cable connected to it is connected to a physical gigabit Ethernet port. So in this one application, you can do everything I say here today on a Pi 3, but you're going to be limited to 300 megabits per second no matter what you do. On a Pi 4, you can get up to a full gigabit per second, and you may run out of CPU power at that point. But I would definitely suggest going with a Pi 4 for the sniffing piece of this. If you're doing something else, absolutely consider the Pi 3. Thanks, Jason. I appreciate it. All right, so send in any questions you got into the questions channel. Jason will do, and Jason and Chris and KC and Keith will all try to answer those. We'll try to get as many questions answered as we can. All right, So as you've seen on that previous slide, what you buy is a bare board that looks a lot like that. And this is a Pi 4 with 4 gigabytes of memory. On the back side, we don't have a slide of that, but on the back side is where you slide in the micro SD card that runs the system. And this can be anywhere from about 4 gigabytes up to 32 gigabytes is easy. It will actually take larger than that, but you only use 32 gigabyte for the root file system. The rest will be data storage. And I've also outfitted this with 2 heat sinks here and here on top of, respectively, this is the processor and this is the Wi-Fi chip. There's one other USB controller chip that used to run very hot, but that's not as much of an issue now. We'll talk about that after the 3 o'clock cutoff if you have questions about that.
We have a lot of people that want to try things like Rita and doing sniffing and stuff, and I think it's somewhat intimidating to try to build something on your own, but on also trying to stand up a notebook computer and trying to do it through that is somewhat not realistic for many organizations. So that's why we wanted to go through with this, and also showing you what you can achieve with a relatively low-powered box. But yeah, the 4 gig of RAM is actually really, really, really important. The CPU is weird. Chris, with the CPU, it seems to me, does it seem to you like the Zeek project is getting more efficient and a little bit kinder as far as CPU utilization over the past, I would say, 12 to 18 months?
Oh yeah, I mean, and even if you go over longer than that, it has definitely gotten more efficient as they've tried to scale this to, larger and larger link sizes. I think that's kind of a no choice type of thing. I mean, unless you're more efficient, you're not going to scale to 40 gigabit.
No, you're just not. But I think the vast majority of people don't actually need a 40 gigabit box. In fact, I think a huge majority of the organizations out there are actually running 1 gig or less for the point of presence whenever they're connecting out to the internet as a whole. Now,
yeah, and this does have 1 gig interfaces. Bill and I have done some testing, and you start seeing some packet loss around 500 megabit. But now it comes down to, if you are saturating a 1 gigabit link, this may not be a good option to go with. If, however, you're kind of average utilization, this might actually work out quite nicely, especially at the price point.
Especially for remote locations. I'm trying to get Bill real quick. For remote locations, I know. Oh, yeah, go ahead.
2 questions. One, would the Pi be like a tap the network team talks about when sniffing on a port?
Oh, that's a great question. So you could use it with a tap, but it doesn't replace the tap. One of the things that Bill has in his parts list is a really cheap Netgear 5-port switch. And technically, that would kind of act like your tap, because you can go in with that and you could say, let's say we want to plug this in just inside the firewall. You could take that cheap Netgear, plug one end into your existing switch, one end into your internal interface of your firewall, and then plug the Pi into, let's say, port 3. And it's a managed switch that Bill recommends. So now you can go into the management software and say, hey, anything going in and out of port 1 or whatever, send a copy to port 3 as well. And that's going to act like your network tap. Network taps will keep up a little bit quicker. I see a question, switch or a hub. It's definitely a switch. You definitely want to make sure that you're supporting bidirectional communication, so it's going to be a switch, but it's an inexpensive switch. Yeah, it's actually a managed switch down around the $35, $40 price point that Bill's using, and we've beat the snot out of the thing, and it does pretty well.
Another good question was, and they're all great questions, was can this be used on an industrial control network?
Oh, absolutely. Yeah, absolutely. That's actually probably one of the really good use cases, because I was talking about your connection to the internet, the internal interface of the firewall. But most environments have one of those, and that's it. I might have many connection points, let's say going to like my PLC, and I want to be able to monitor that. Yeah, go out and buy like four Pis. You're probably still at $1,000 or less, and you can monitor all of those individually. Send all the data back to a central location.
So the board slides down into the Raspberry Pi case. There are a number of different cases you can use, and it really doesn't matter which one you pick. The one thing to keep in mind is if you're doing packet processing, especially at high rates of speed, you may very well want to leave the cover entirely off. It's not a great way to go to try to do this with the cover on, because it'll keep the heat inside and there's no way to put a fan on top. That said, there are some fan units that you can put on top of the Raspberry Pi itself, and these would fit inside of a case. Just keep in mind that the airflow is important. If you need to use a keyboard and mouse, the keyboard and mouse hook on to the USB ports on the end. Use the black ones for those because they're low speed. If you need a monitor to do the initial setup, hook up a micro HDMI to HDMI cable. That will come in the Cana kit, or you can order it separately if you need it. You don't need it for long-term use. You usually set these up and then you won't hook up a keyboard or monitor or mouse to it much in the future at all. Do most of your work over SSH. Power goes in here. It's a USB-C connector. And that looks like a white cable that plugs into the USB-C power port. The sniffing, as I mentioned before, is done off the wired gigabit Ethernet port. So this goes to your span port, mirror port, tap, copy port, whatever it happens to be called. All the packets come in here. You don't use this for normal communication. To do normal communication, what you're going to use is a USB to Ethernet adapter, and that's listed in the parts list. You plug that into the black USB 2.0 ports. I'm not going to go deep into it right now. I had some compatibility problems when I tried to run it on the USB 3 port. It's not worth digging into at the moment. It may have been fixed with new firmware, but let's assume it hasn't. This runs just fine on the USB 2.0 port. It's plenty for patching, remote access, anything that this unit needs to do with the internet. And as I said, a fan is very useful. If you don't want to plug a fan right on top of the unit, you can buy a little USB fan that plugs into the USB 2.0 ports, or 3, but 2. You want to keep the 3 available as much as possible. And the fan simply blows down onto the system, keeps it cool. All right.
Hey, Bill.
It's a little, yes, please.
There was a question, could these be used in harsh environments, like really, like the hot Arizona sun, or do you need better conditions?
I think
it probably would work.
Can't you, Bill? Like, I think you can get more rugged cases with better fans and better cooling. You can buy those, but I think the one that you're building out right now, you wouldn't want to leave it out in the sun. That sounds bad.
I don't think so. It's not a great call. So one thing to keep in mind is that when these overheat, when you get up to 180 degrees Celsius, the processor automatically slows itself down to 2/3 or half speed, depending on the temperature. So if you get something that's way out in the hot sun and it is just getting roasted, what you're going to find is that your performance is going to be terrible because the processor keeps having to slow down to try to cool itself off. You can try it. Worst case is you've lost a $35 circuit board. See if it works. And
I just did some quick Googling, and there are like industrial level Raspberry Pi cases that you can actually buy that have a better heat sink and better fans, but they're way more expensive than the Raspberry Pi itself.
Oh yes, yeah. You get active cooling. It's absolutely worth doing. You can get multiple fans built into the case. You can get cases with huge heat sinks. Lots of possibilities. All right. For software setup, once you've installed the micro SD card, which is nothing more than sliding the card into the slot at the bottom, into the micro SD port, boot it up, hook up a keyboard and mouse, hook up a monitor to HDMI 1, which is the one closest to the power connector, I believe, and you get the operating system install coming up. The prompts are relatively straightforward. What's your time zone? What kind of keyboard and mouse are you using, and so on. You'll want to buy a microSD card with a software installer called Noobs, N-O-O-B-S, new out-of-the-box software. And Noobs comes with Raspbian right on the disk. If you decide you want to use a different flavor, it will go and pull that down from the internet, install it just fine. You make your choice of what to use. Once the system has booted and been loaded and rebooted, you'll be able to SSH to the user pi at raspberrypi.local. And that's a multicast DNS or link layer multicast name resolutions, one of those two. It's broadcast onto the LAN so that you can SSH right to that without having to go and set up DNS. Make sure you change the password of Raspberry as quick as you can because that's a well-known password. And if you have trouble locating it, use the ARP command to look for the MAC address that starts with DC A632, which is the block allocated to Raspberry Pis. All right. So we'll set this up with the wired Ethernet port for sniffing. There's no need to have an address. All it's going to do is accept packets from the span or mirror or copy port. We'll do our sniffing on there, and then anything else that we need to use for internet access, we're going to use the USB to Ethernet port for its internet access, for remote access, for patching, for transferring logs, for whatever you need to do. I'm going to briefly just go through these. This is for Debian and Ubuntu Linux. If you edit the file etc network interfaces, here's an example of the lines that you need. Some of you may have already looked at the zip file that I sent out with scripts, and I've got some sample lines to add to many of these files that match what you're going to see on these slides. So don't feel like you have to write these down. They're in the zip file that's downloadable. This just tells the system to bring the interface up and make it promiscuous so that it will accept packets from the outside world by default. I'm also going to tell the system not to try to get an IP address for DHCP through DHCP by this change to dhcpcd.conf. Jason, what have you got for us?
Quick question. Could we have the device in line for layer 2 sniffing, so no IP address changes?
Yes, you actually could. So in order to do inline, you still need 2 physical Ethernet ports. You put one on one side of your network and hook one up to the other side of your network. You'd route traffic through here. Bridged firewalling is, I think, what you're referring to. And this is where there's no IP address assigned to this at all, either port. You set up firewall rules, or you set up an IDS that's in between for the traffic flowing between. You turn on IP forwarding. There are a number of different steps you have to do, but Linux handles that pretty elegantly. One other nice part is if you use this approach with a gigabit port on one side and a gigabit port on the other, you still have the wireless network so that you could SSH in and do maintenance and checks and any other tools that you need to run. What else have we got, Jason?
Why Raspbian over Kali ARM image?
I have no opinion about any particular choice of distribution, or even the fact that somebody may say, I don't even like Linux. Can I use something else? Use whatever you're most comfortable with. I use Raspbian because it's the default operating system that comes and is usually installed on Raspberry Pis. But it's certainly not the only one, and I've used so many that I'm just kind of used to all of them.
I would say with anything, anytime you do that, always start with the instructions like what Bill's doing right here. And then if you want to get creative, do that. Because then you have an idea of what works. You have an idea of what it's supposed to look like when it works. You don't want to be troubleshooting 4 or 5 different things at the exact same time.
Perfect. And the other thing to remember is buy a second card with Noobs on it. Use this as your default test environment. Put Raspbian on there. Just get comfortable with the environment. Take this one out. Put another Noobs card in, and then say, hey, I'm going to use LibreElec, or I'm going to use RISC-OS, or I'm going to use some other totally different OS. I'm going to put it on this card, and now you can try it out for nothing more than a $10 micro SD card.
Then
Thanks, John.
Lastly, someone asked if you need to be a Linux expert in order to set up a Pi.
No. This, by default, as it comes out of the box, it's set up to be a desktop OS, meaning that it's got a Linux graphical desktop. You can absolutely use this with graphical applications. You can learn how to do command line tools if and when needed. You can use the graphical tools for the rest of the time. If you're going to do things like this, where you're setting up a remote sensor that's going to run independently and doesn't need somebody sitting at a command line, just expect that you're going to learn some things during the process, and you may need to go and nudge a buddy or ask on an internet mailing list for help. Doing some of these command line tools can be a little bit intricate, and sometimes it's helpful just to have someone to nudge. I have gotten more help out of the years from people than I can even begin to recount. All right, so we're not going to ask for an address from DHCP for the ETH0 interface, and I've included some additional lines. Again, you don't have to type these in, they're in your zip file, but I've included some examples of how to go and set up the system. The first command simply turns off some of the processing that would normally happen on ETH0. It helps the sniffing work better. The third command down here with the screen simply sets up TCP dump running in the background. And every hour, it creates a brand new file of packet captures in opt-bro pcaps and compresses the old file so that you've got some logs that you can work off of and do testing with, not always having to have a live feed of packets. Down here with Zeek control deploy, we make sure our bro package is running. And I'm going to cover PiShow briefly at the end when we talk about the display that's on top. Let's leave that for the moment. I want to make sure we get through the rest. We set up the storage on an external drive. Remember, we talked that the micro SD card only has 32 gigabytes of storage, maybe a little bit more. You can actually buy larger ones, but it makes more sense to go with an external SSD. In this case, this is a Samsung T5 SSD. I happen to go with a 500 gig version, but they have different versions, I think, that go up to, I know for a fact they go up to 2 terabytes. So you've got plenty of space to store either raw packet captures or bro logs or something else. And the scripts that help set this up mount that on the opt-bro directory so that everything underneath that gets stored on the external drive. The scripts file, as I talked about, those will turn on SSH so that you can SSH into the unit. They patch the system, they put in some needed tools, they format the external drive, and they force ETH0 to have no IP address. I'm not generally encouraging you to just run these blind. Take a look at them first, make sure they do what you want. If your environment is set up differently than mine, they may not work for you. If you've picked a different operating system, they may not work for you. Just get a sense of what's there rather than running them, and use them as templates for how to set them up. Your needs may differ from mine. For example, I sort of assume that you don't want the graphical desktop. There are commands in there that will disable that and return a little bit of RAM to you for network packet processing, but you may want that desktop on. So by default, I've commented those lines out. Take a look at the scripts and make sure they match what you need. If you have bugs in them or if you have suggestions, send them in. We'll go and send up new versions if there are things to get fixed. What have we got, Jason, other than a cute little cat?
I know he came and now he's in my way. There we go. All right. I'm getting questions about Elk. So one is like, can I install FileBeat or AudioBeat on this to send it to Elk?
I can take that one, Bill.
Please.
Yeah, don't. So what you're doing with this is you're probably pushing this box not to its limit, but close to its limits. Whenever you're running something like Zeek and you're doing sniffing with the Raspberry Pi, as soon as you start putting other things on top of it, you're definitely going to severely, heavily impact the overall performance of this. So generally what I would recommend, if you're going to be doing something like an elk stack, do a separate computer system. And then you can basically have the logs from this either are synced or moved over to that system. Let this do what it does, which is basically capture packets.
Yeah.
Perfect. I completely agree, John, especially with the idea that packet capture needs to be something that's very low latency. When you're doing packet capture, you generally want that box mostly focused on that one task and then do all the processing elsewhere, whether it's a Raspberry Pi or it's a high-end box. Try to do all the processing somewhere else.
And the other thing that's hard, in a lot of ways, you don't get good feedback that it's starting to drop packets unless you know where to look for different statistics for the adapters or looking in the Bro logs or Zeek logs themselves. It's not something that will be readily apparent. And we've had customers that have completely overburdened a box and they've sent us their packet captures and they're like, here you go, here's your packets. And it's like, this is literally 10% of the packets. You have a 90% packet drop. And it's just give it lots of memory and get it a dedicated box and you're going to be much better in life.
Completely agreed. No virtualization, give it raw hardware, get the packets as directly as possible. Agreed. Hey, thank you guys. So the last issue, and the one that's kind of sometimes glossed over, is actually getting the packets. If you've got a switch that that has a mirror or span port, or you've got a packet capture architecture where things come in from different sensors, they're shunted off to different IDSs and sensors and other tools, great. If you don't, one of the easiest ways I know to do this is a Netgear GS305E. There's a link to that in the parts list. This is a 5-port gigabit Ethernet switch. It's about as simple as you get, but the one thing that's really nice that you get over an unmanaged switch is that with a web interface, you can tell it, I want every packet that arrives at port 1 to get mirrored to port 5. So you use this as your link to your router. You put port 2, you connect that to the internal switch where all of your clients connect, and then port 5 is the Ethernet cable that leads to your Raspberry Pi. Everything that goes back and forth between ports 2 and port 1, i.e. your switch going to the internet or the internet coming back to your switch and your clients, all of those get sent to port 5. And that means that you can capture all of that traffic and send it to the Raspberry Pi. It's a relatively quick change. You go into the network interface, you say, I want to turn on mirroring. I want all packets going to port 1 to go to port 5, and you're done. You should be aware this is a low-cost, relatively simple way to get the packets going, but you also need to be aware that if these are running at full capacity, you have a gigabit of traffic going to the internet, and you have a gigabit of traffic coming from the internet, 2 gigs. And those are getting stuffed out a physical port that cannot move more than 1 gigabit per second. You've automatically lost half your traffic. So this is not what you put in a very high bandwidth environment, but it is a wonderful way to do a proof of concept and say, this is what we can do with a Raspberry Pi. And if you need more capacity, you can absolutely move that up. This is, I think, $33. Note that make sure you buy it in the country that you need to use it in, because it only comes with a power adapter that works with 120 volt in the US, 240 volt in the UK, or get a power converter. All right. To actually watch the span port, you can use the ifconfig command and say, am I getting packets on this port? So by running ifconfig, you will see a number next to RX bytes and RX packets. RX bytes is what you're looking at. That number should be going up very, very steadily if you're getting packets from your mirror copy span tap port. If you're not, if that's staying close to 0, go check your mirror setup and make sure that you're actually feeding out the packets you expect. So costs about $250. A case is nice, a fan is nice, external storage. I've shown you doing this with an external SSD. I've actually got a test model that I use here in my house, and this is a fully running version of what we've talked about. And if you'll notice up at top center, I'm just using a thumb drive, 32 gig thumb drive. It's not fast, but it's plenty for storing bro logs. And then I've got the sniffing port here. I've got the USB to Ethernet port here, the power adapter. And because it's all set up, I don't need to use the HDMI ports or plug in a keyboard. We'll see a little bit more of that in just a minute.
So we just had a question. Someone said, have you tried running this with a power over Ethernet adapter? I don't think it uses that much power, but it might be a bit sketchy. What are your thoughts, Bill?
They do have power over Ethernet adapters for this. So what happens is, if you want to use power over an Ethernet, you can't just use the base Raspberry Pi. You have to buy an additional circuit board that goes on top that takes the 2 power over Ethernet pins, or 4, I can't remember, and then actually feeds that in to run the Pi itself. But you can do that, so you can run this whole thing on a power over Ethernet approach and then not have to use this. If you're not using a whole lot of additional peripherals, that should work fine. If you're trying to power 4 rotating media physical hard drives off of these USB ports, no, it's not going to work. But for an SSD, the power usage is far less than a rotating media drive, and you get much lower latency to start with. Jason.
So on a typical home network and an external 500 gig SSD, how long would it take to fill up that 500 gig SSD?
Not your home, Bill. Not your house.
Weeks or months. I grant you, my house is going to be different than your house, and I think Chris Brenton will back me up on that statement. But for a normal home network, a small branch office, a subnet that's relatively light on traffic, months. You shouldn't run low on capacity for a long time. And then if you think you've got very high bandwidth requirements and you really want to make sure it could never run out of space, just go up to the next size up. They have 500 gig, 1 terabyte, and 2 terabyte models that aren't all that much more.
Interesting question just popped up, Bill. Could you whitelist out packets going to Netflix or something to not be captured to help manage capacity?
100%, absolutely. So with Bro, and frankly with every sniffer that I've come across, there is some way to use what's called a Berkeley packet filter, or BPF. The BPF says, I don't want you to process this type of traffic. Let me give you the simplest example of that. Let's say I know I've got a NAS that runs on SMB. So I could put in a Berkeley packet filter that says not UDP port 137 and not UDP port 138 and not UDP port 445. Literally all those words separated by spaces. And that would tell my Bro sensor, look, even if those packets come off the wire, ignore them. Don't process them. Don't try to summarize them. Don't try to chew them. Don't touch them. In fact, the kernel never even hands them up to Bro if you use that approach. And that means that Bro can skip high bandwidth stuff that you don't care about and then focus on the lower bandwidth stuff that you do care about. If you've got a system that's running too heavily, that is a great way to go and filter out the traffic to just the stuff you care about. Excellent question. Thank you very much. In fact, if you slide back on the slides, I'm just going to briefly touch on it quickly. The rc.local slide has a reference to that.
And Bill, while you're looking that up, have you ever set this up on a wireless kind of environment yet?
I haven't, but it's not that it couldn't. You do have to pay attention. If you're looking at sniffing the wireless side of it and you're trying to get promiscuous what's the word for when you're looking at the wireless frames as well?
It's still promiscuous, yeah.
Promiscuous, okay. There's depending on the type of adapter you have, you may or may not have the ability to grab other types of wireless traffic. I've never gotten a good answer on whether the Wi-Fi circuitry on the Pi can do that, but you should absolutely be able to sniff normal IPv4 and IPv6 traffic over Wi-Fi.
So one of the problems that I've ran into with it is if you put your wireless access point and then you put the Ethernet adapter to the WAN interface and then you plug it into the Pi for packet capture and then you connect it to your internet provider. The problem is everything looks like it's coming from the wireless network. So usually what you have to do is you have to set up your wireless network in, well, there's a couple of different ways. You can get a wireless router that actually supports fanning and throwing packets to the Pi. And you can buy like a commercial FortiGate for pretty cheap. That'll allow you to do that. The other thing that you can do is set it up so your wireless network is merely set up as a bridge for your router, your real router. And then your router actually sends it through, and then the edge router does the network address translation. You will have to do some shenanigans, like you're going to have to play around with it, because by and large, the Soho wireless routers that you get for home use are complete garbage, and they tend not to have the capabilities that you're looking for. One exception from this is the MikroTik wireless routers. MikroTik wireless routers can actually establish a span port and can throw packets to these. However, you're getting a somewhat possibly sketchy device that you're putting on your network. I wouldn't ever use it in enterprise, but the MikroTik stuff is pretty cool.
MikroTik, they happen to be Linux-based routers, and you've got they're so full of features. If you want to be a packet geek, you can actually have these things ship you PCAPs directly sniffed right on the router. Well worth it. Hey, so I backed up real quickly to the rc.local slide, and there's an example of a BPF here in between quotes about halfway down the screen. I can't select it because of the way the slides are working, but parentheses TCP13 ampersand 0x17 not equal to 0x10 or not TCP. That says, give me everything that isn't TCP, UDP, ICMP, everything else, and give me the SYNs, SYNACs, FINs, and resets, but not the body of all the TCP packets. So I get some summaries of the start and the end of every TCP conversation, but I don't get all of that body stuff in the middle that takes up so much bandwidth. So that's an example of a BPF where I'm limiting what I see to allow the program to keep up with even high packet rates. Hey, excellent questions, guys. Thank you so much. Let's keep going here.
We did have some people that brought up monitor mode. So there's a difference. If you're just doing straight wireless sniffing and you're not associated with a channel, or not associated with anything Ethernet related, then you're in monitor mode. However, with tools like TCP dump, you can actually join a channel and you can still run technically in promiscuous mode with your Ethernet adapter. So it has a lot to do with whether or not you've joined a network. And that's kind of a difference, Bill. I would say if you're just sniffing wireless traffic, you're doing monitor mode type stuff with like with various wireless tools. But whenever we're talking about actually grabbing this, we want those Ethernet frames. And one of the problems with trying to pull down Ethernet frames is if you're just running in monitor mode, you're not going to be pulling down the Ethernet frames unless you strip the wireless frames off. And tools like Kismet do have that capability where it'll strip off the wireless header information, and then it can pass it over. It can pass the Ethernet frames over. So it depends on whether or not you're actually joining a network. And that really does matter, especially whenever you're using tools like Bro and Zeek. If you're just pulling wireless frames, it's not going to recognize anything. So just a little bit of clarification.
Yeah, and I'm not sure if the Wi-Fi circuitry 802.11, it's 802.11ac. I've gotten conflicting answers on whether this can run in monitor mode or not. The nice part is, even if this is total garbage and will never do the type of sniffing you want on Wi-Fi, you can always do a USB-based Wi-Fi adapter that does support what you need and runs under Linux. So it's just a question of whether it's built in or not, and I can't tell if it is or isn't.
So Bill, we got
So
another question from Jim. He
please.
said, will this configuration Pi4 and Zeek work if your network is segregated with VLANs? That's an interesting question.
Yes, you need to make sure that you're using Zeek or Bro, and I believe it's 2.5.0 or higher. And in that configuration, if you have that version or higher, the software will recognize that it's got VLAN or tunneled traffic, strip off the header, and give you both the outer packet and the inner packet, as well as a connector between the two, so you can do analysis and say what tunnel was this found in. Earlier versions will just look at the outer VLAN and just say, well, that looks like VLAN traffic. I can't find any TCP anywhere, so I'll just kind of ignore it. But as long as you get 2.5, I believe it's 2.5.0 or higher, you're all set. All right, so for what tools can you use, you name it. The list of tools that you could use is immense. Anything that will run on Linux is the first answer. tspdump and tshark are just great if you're doing command line analysis of packets. You want to grab everything, you want to do some basic analysis, great. With Zeek or Bro, they're two names for the same package. They will come up with summaries of all the connections that you've got, give you some analysis of weird traffic, pull out DNS requests, look for HTTP headers, look for TLS signatures, some great stuff in there. You get these one record per line entries for each of those types of traffic that are stored out in ASCII text files that are either tab or tab separated, or they are in JSON format. Suricata or Snort, you name how high you want to go. You can even do the capture on this box, send the PCAPs over to somewhere else and do heavier analysis there if you find this box can't keep up. If you got enough processing power, run multiple tools. In this example, we're using the box to capture PCAPs with tspdump. We saw that line in rc.local earlier where tspdump runs in the background and stores an hour's worth of traffic in individual files, compresses them at the end. Zeek will look for summary data, just in case one data wasn't enough for you. We're going to look for summary data for security review. Zeek will kind of take those raw PCAPs and give you a summary rather than individual packets. And then Rita is the next level up. We're actually going to look for command and control servers inside the traffic based on these Zeek or Bro logs. So this is, again, the example of capturing with tspdump, and what you get in the opt PCAPs directory, or opt Bro PCAPs more accurately. I think I pasted my slides a little off. Is the name of the host, the timestamp of the packet, and the packet capture file. To install Zeek and Rita both at the same time, go up to github.com/activecm/Rita. Rita is an open source tool. We have both video blogs and text blogs on how to use it. If you go down to install and grab install.sh, you can run.
We have a quick question. People are saying, are we installing Rita on the exact same box?
You can, absolutely. Yep. You have, yeah, absolutely. So you've got a lot of processing that needs to happen with Rita. And what I'm suggesting is if you do your packet capture just like normal, and then you run Rita, especially if you put the word nice in front of the command line where you're running Rita, Rita can run in a way that lets the packet capture get first dibs on the processor. And then Rita itself will take whatever processor time is left.
And that, I just want a little bit of background. If you remember Rita from people are kind of, I've got Martin, who, Martin is awesome. We've had a number of people that are kind of coming in, and Martin was one of them. He's like, are you sure? And the answer is exactly what Bill said, yes. Because if you go back like 3 years ago, Rita was a CPU hog. The algorithms were not as optimized as they are now. And as Bill said, the idea that Rita can sit back and say, whoa, I'm not processing, that CPU is at 100%. And then whenever the CPU starts to slack off, then it takes over and then it starts doing its processing. That's awesome. And that's like Bill and Lisa and a bunch of our developers and Logan working on that. So yeah, we intentionally created it so it could do that type of awesomeness. So sorry, Bill, keep going.
Absolutely. No, and the credit goes to the other developers. I'm the guy who just gives them headaches. That's all I do. Absolutely. So pull down install.sh. If you run that, you have sudo /install.sh. It will install Bro for you. It will install Rita for you. They can go onto this system. You can run them right here. And again, you don't have to run them all right on this box. You can absolutely go and break them up and put the analysis onto another system. That's just fine. And John, just for reference, your webcam is still on if you'd like. Do you have other questions? Hey, cool. All right. The Bro output logs are going to get stored under /opt/bro/logs. Current is the subdirectory where the currently created logs are going to get stored. At the end of every hour, they get copied over to a directory called 4-digit year -2-digit month -2-digit day. And you can look at them as is. They happen to be compressed, but you can look at them directly, or you can process them with Rita. So why wouldn't we just use a normal PC? Well, there are a couple of reasons. One is the cost. Depending on what you get, how much hardware you get on each one, this can be 1/3 to 1/20th of the cost of a PC or rack mount device. If you just want to do a proof of concept and say, look, this is what we could do at all 12 of our branch offices and look for malicious traffic, that's great. That's an easy way to get things going without having to spend thousands and thousands of dollars. Second is the size. This unit is basically about the size of a credit card and a little larger. You can hide this behind almost anything. You can put this in a networking closet in a place where no one is going to find it. You can put this in a break room that just happens to have a wired Ethernet port, leave it, come back in 3 weeks and just pick up the packets, do your analysis, and then prove to your customer that their security is not very good. I was told not to use the word I was intending to use by Jason, who's watching very nervously about whether there's a mute button for Bill. There isn't. Downsides? It's a moderately powered CPU. Don't let me give you the impression it is underpowered. It's a 1.5 gigahertz quad-core ARM processor, but that is comparable to a low-end Intel PC. Don't expect this to be a powerhouse of processing. It is very good. It's not the fastest computer you've ever used because we're all used to high-powered machines. At the moment, you can get only 4 gigabytes of memory on it. I did see a recent webcast where somebody pointed out that the board design actually would accommodate an 8 gigabyte chip, just nobody's making it right now. Not a big deal, but at some point in the near future, you might see an 8 gigabyte version show up.
So we had the same question come up a couple of more times. I just want to make it clear. Bill, people were saying, hey, can I run Elk on top of this? Don't do that. Please, for the love of God, don't stop. If you are setting up everything and you're like, I want to put Rita and Zeek and Elk on the same system, just lay down on the floor, put a nice ice bag on the top of your head, wait for that urge to pass, because Elk by itself is tough to get installed on 4 gigs or less to the point where it's actually functional. We're going to crush this box. So you would want a script to get the logs off rather than just putting Elk right on top of it.
Use rsync to take the logs, pick them up once they've finished processing at the end of every hour, send them over to your Elk's machine. Absolutely. And in fact, that's the reason why this particular unit was created. We needed an inexpensive processor that would send the logs over to an AI Hunter machine remotely. And so this was what we call our Pi sensor. It's essentially what you're seeing today, with the exception of the display, and I'll talk about that in a minute. All right, what else could you do? Additional network interface cards connected to USB. You've got 4 more ports. So you've got 1 wired, 4 USB, and also the wireless network. You could have 6 interfaces that you're working with. The live display is what I've talked about. It's going to be almost impossible to see this, and I apologize. But if I hold it up really close to the webcam, I might just be able. No, it's going to be hard to say, sorry. This is the graphical and text-based display that we put onto the 40-pin header. And it lets me send out both status messages like the IP address, as well as error messages saying, oh, you're out of space, or I am not getting any packets on E0, or I can't find an internet connection and things like that. You can show the temperature, for example. Remote access, you can send files in or send files out via USB, Ethernet, or Wi-Fi. If you need more processing power than one of these can do, maybe a cluster. Might be a little bit too geeky, but you can certainly do it. And also physical monitoring. There are different sensors that you can use for environment and camera and so on. I won't get into those today because we're cutting it close on time. Power, you could run this off a battery or solar. It's a little bit tricky, but you can do it, as well as Wi-Fi sniffing. We've talked about that earlier. The 40-pin connector, we didn't talk about that much, and I think we're close on time, so we won't go into it too much more. But for example, this is the audio card that you can buy that goes on top of the Pi for high-def audio in and out. And I did a project for a musical group where they could rehearse with each other, even though they were in 4 different states, and low latency audio between them. Lots of additional stuff. We'll skip those. Cellular and GPS and alarms, and even a little camera circuit that plugs right onto the Pi and gives you a camera of where you are. So if you want to snap a picture every 5 minutes and say who's going to the break room a whole lot, you can do that. So we're down to references. You can see these at the end of your copy of the PDF. Tutorials, references to the kits that you can buy. I'm not going to go through all of these, but I hope you'll take a look. In particular, I'm going to back up one slide. Adafruit's Learn area, tons of things, and they've really done a nice job of covering all the things you can do with a Raspberry Pi. Let me leave this one up. So the shopping list of where to buy the parts is up there. Pull that down along with this presentation. That will also give you the links that I just skipped by way too fast, and also the zip file with the scripts. I'm going to leave this slide up while we wrap up the talk. Jason and John, other questions?
I can't keep up.
No, there's a ton of questions, and we're going to try to rapid fire as many as we can during the post-show banter. Bill, any final words today?
This is one where it's really hard to overestimate how many things you can do with this. We're used to a very high-powered, very expensive laptop or desktop for our own day-to-day use. This is the other end of the scale. This gives you some possibilities that you just couldn't pull off with a high-end PC, but now you can do all kinds of stuff with a low-end one. It's well worth just getting one, trying it out, and saying, hey, that's cool, or oh my gosh, this guy is on crack. Where did they give him a webcast?
Thank you, everyone, for being here for this Active Countermeasures webcast. Anything, John, before we go?
I'm sorry. I am so sorry to all of you if I didn't get to all of your questions. We were trying to answer them as fast as we possibly could. My fingers are burning.
We had 837 people on today. It's unavoidable. Thank you so much, everybody, for taking the time out today.